Okay, I'm gonna start. Alright, this part, today's lesson, right, is really just about problems involving perfect squares and if I have time, I'll go on to square root. Okay? Now, this is an important component because it will definitely come out in exams. Okay? Not just because of that, because I would like you all to see that, you know, when it comes to product of prime factors, there's actually a lot of things we can do with it. Okay? There's many things we can deduce from it. Okay? The idea behind all these examples that I'm going to show you here, okay? Thank you. Okay, the idea of all these work examples is really to see the beauty behind prime factorization and the product of prime factors. Okay? So, the very first one we have is work example 3a. I write wrongly. Okay, when I say WE doesn't mean we, it means work example lah. Okay? So, work example 3a. Okay. Please pay attention to this, to how I analyze the question. Okay? Written as the product of its prime factors, 360 is equals to 2 cubed times 3 squared times 5. That is the given condition. I'm going to write it down. Okay? The next part of the question, come read with me. Find the smallest non-zero whole number, P. Pause here. Okay, the clue here is, what is P? No, read the question again. What is P?
Smallest non-zero whole number.
So P is a non-zero whole number. Means P can be what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can it be 0?
No.
No, cannot, right? Can it be as big as possible?
1 million.
Can it be 1 million?
2 million.
Possible, if it is the smallest possible. Okay, but let's look at what is the smallest possible, depending on the question. Okay, so let's continue reading. Okay, so we have P is a non-zero whole number. You don't need to write, those in blue, no need to write down. It's not the answer. It's just what I'm going to, non-zero whole number. Okay, let's continue reading. Okay, find the smallest non-zero whole number P such that 360 times P is a perfect square. Read the question. The question is there. Okay, who is the one who said whole number? No, don't do whole number. Okay, 360 times P is a perfect square. Okay, so we have here the other information that we have is when I multiply P to 360, this apple here, that is the value. It's an apple, it's an apple. It's an apple. What are you thinking again?
Cherry.
Cherry, whatever. This cherry here is a perfect square. Okay, so quick recap. What is a perfect square? Example. Hey, no, hey, come on. This is just a cherry. Okay, 2 squared equals to 4. Right? So this means that 4 is a perfect square. Correct? This is what a perfect square means. Okay, look at how I break down this question. Okay, don't worry about long questions like this. All we need is to break down the question. Okay, now the idea here is to actually find out what's the question asking? Asking for P, which is this over here. Okay, but we have this cherry over here, which I don't know anything. Oh my goodness, I hate cherries. I don't know anything about cherries, and honestly, I really don't like cherries. Okay, there was this day, a teacher, he was very nice, okay, because I helped him do something. He bought me a whole bag of cherries. I mean, some people love cherries, I understand, and he wants me to be healthy, you know, have a healthy lifestyle, eat fruits, right? But I don't eat cherries. I don't like it. I don't like the taste of it. So in the end, I brought the whole bag of cherries. I brought to and go all the way to my fiance's house. Then I tell her, hey, can you eat this for me? Because my fiance eats everything. Okay, she really eats everything. Okay, so yeah, that's how I'm gonna use cherry here. What?
She eat
What? You think heavily, I give you 2 seconds. 3, 2. You think heavily. Okay, come. So now this elephant in the room, this cherry in the room, we're going to deduce what is it first. because this is going to help us deduce what is P. Okay, I say again, the idea here we know that is that this entire value here, okay, this cherry in the room is a perfect square. Okay, this cherry in the room is the perfect square. But I'm going to remove the cherry first. I don't like the cherry. Hate it. Now I'm going to replace it with what I know. I'm going to replace this statement with what I know. No lah, what I know. So what I have from that question is that the question provided me with the prime factorizations, right? The product of prime factors. So I'm going to replace it 2 to the power cube times 3 squared times 5. Am I done here? Does this make sense?
It will be times P.
Why must times P?
Because this thing is equal to 360.
Correct. Because this entire statement, this 3 product of these prime factors is equal to 360. So I must leave it times P. Then it will be equal. Okay, the two of you, okay, my camera can hear you all. So if you want to, I can post this part where I have to tell you all to stop talking. I don't mind.
Okay.
Okay, you want to be famous?
Yes.
But no, people will know you. Yes, correct. You will be infamous for talking my lesson. Okay. So now, how to do this again? The cherry is still there. The cherry is something I really hate. Okay, but what is the thing we know here is that this has to be a perfect square. Correct? And one unique thing about perfect squares, for example, okay, is that let's say I have one that is 2 to the power of 4 times 3 to the power of squared. If this is a perfect square, okay, let's say I call this number A. Okay, let's call this number A. Okay? If this is a perfect square, when I square root A, I can simply square root the prime factors, right? And I can simply get 2 squared times 3. Correct? From what all the examples we have been doing, this is a unique thing about perfect squares. I can easily find the square root of a number, in this case A, by simply just square rooting the product of its prime factors. Okay, I'm going to reverse this idea into this. Yes? Very confusing. Wait, okay, don't worry. Okay, so if this entire thing is a perfect square, okay, how can I make all these become a perfect square by multiplying a certain number of P? I say again, this requires a bit of trial and error. How can I multiply P such that all this thing here becomes a perfect square? And it must be the smallest, is the smallest, which I never write just now. Smallest non-zero whole number. Okay? So what is the minimum number that we need to multiply? If I want this to be a perfect square, right, technically all the powers here should be a even number. I say again, if I want this entire thing to be a perfect square, the powers should be an even number. So I'm going to do a bit of trial and error. Okay, I'm going to write the prime products for the first one. Okay, then if I want to make this even number, I must multiply how much to make it an even number? Smallest, multiply 2. Okay, we multiply 2. Then this one, need or not? Is it even already? Is the power even? The power is even, right? I don't want to touch all. Now this, is the power even or not?
You have power.
Do I have power?
So it's not even odd.
The power is 1. Okay, all numbers have a power of 1. Just that we don't write it down because it's invisible. Okay, we will never write the power, oh my goodness. Okay, we never write the power of 1 because it's just a number. So technically to make this to an even number, to make it 2, right? I can just multiply 5, correct or not? Correct? Right, it makes sense, right? If I want to make the powers even, I just need to multiply another number to make it even, right? So the next step is I'm going to combine everything, and I have 2 to the power of 4 times 3 to the power of 2 times 5 to the power of 2. Can this number be a perfect square now?
Yeah.
Can, right? Because when I square root this whole thing, I can easily get the answer. Correct? Now, so can I deduce here that the number P is equals to 2 times 5? Trial and error. Can I deduce that P is equals to 2 times 5? Can, right? But the next question, is it the smallest possible? The smallest number it can be to make this a perfect square. That's what the question is asking. Is P the smallest non-zero whole number to make this entire thing a perfect square? You must ask yourself this. Because technically, if you think about it, I need to make this even, right? Can I multiply 3 to the power of 3? No. Why cannot? I can make this even, right? It becomes 2 to the power of 6, right? No. Then this one I also can multiply 5 to the power of 3, right? Then I can make this 4. I can make this 6. It is still a perfect square. Right? It is still a perfect square. But why I cannot do this? As what you say, why I cannot put 3?
Smaller.
Correct.
Bigger.
Smallest. This is quite big, you know. This is 8 times 125. Eh. Well, the smallest here, if I'm going to use the smallest here, okay, I will still get a perfect square, which is 4 and 2. And hence the answer is P is equals to 10. Because this is the smallest possible value of P, such that when I multiply P to 360, I will get a perfect square. You don't believe me? Let's try it. Let's test it out. Okay, if you don't understand this, I implore you to relook at this example at home. Okay? So let's try 360 times 10. What do you get on your calculator? Okay, then you'll go and square root this number. Is it a perfect square? Use your calculator to square root it. Let's try. Is it a perfect square? What's the value? See, it's a perfect square. Okay?